All right, we are going to go over charging by conduction. All right, so one of the keys to remember the difference, because we're going to do charging by conduction. The next video is going to be charging by induction. All right, so they sound really similar. What are some of the differences? Well, up front, okay, what's going to separate these different types of charging is some of the behavior that is required to charge by conduction compared to charging by induction. So let's say I had use black for this. I had a rod that it was charged. All right, let's say it was positively charged. Okay, and again, some of this is we're doing it for simplicity's sake, not necessarily because it's always the most accurate. I mean, they're not lined up like this in an actual solid. Just because it's positive doesn't mean there's positive charges everywhere. There's still trillions of negative charges on this positively charged rod. All this is saying is that there are more positive charges than there are negative charges. That's all we're saying when something is positive. It doesn't mean there's an absence of these. It just means there's more of these. All right. So again, we remember that positive charges cannot move. Right? They are in the nucleus. They are protons. They're not going to change and move around. The only thing that can move are the negative charges, which are the electrons. All right. So that means for this to be positive, it must have lost some electrons somewhere. You know, we can either through tribal electricity by friction, it could have lost some electrons to some other cloth or material or another pathway. But it has more positive charges than negatives, so it has an overall charge that is positive. This has equal positive charges and negative charges, all right? So we would call this neutral. All right, it's got the same amount, so it's a neutral object. So we want to charge this. That's our goal with what we're trying to do. All right, so if I want to charge by conduction, what I would have to do is I would have to actually make contact. Okay. And so now this rod I brought close, made contact, and just to be accurate, we gotta make sure there's a couple negative charges in there somewhere because we want to show that they are still present. All right, so contact is made with this neutral object. So what's going to happen? Think back to our sticky tape lab where you had a charged piece of tape, positive or negative. We didn't know which, but we knew they were opposite charges, and they both attracted a neutral object, which means something happened there with that neutral object for that interaction to have occurred. So once a positive charge gets close, again, the positive charges never move, but these negative charges become attracted, right? Remember our fundamental rules of charge: like charges repel, unlike charges attract. So these negative charges came close to here as it approached, but once it made contact, these negative charges would leave the neutral object and move into the positively charged rod because they are attracted to each other. Positive charge, net charge on the rod, negative charges on the neutral object. Those electrons will leave this neutral object. Obviously not all of them. It'll be a large number still, but there's still an exponentially larger number left on this object. All right, so it's going to lose some of these guys. All right, then let's say we pull it back away. All right, so now we pulled this away, okay, and we've actually picked up negative charges. So this is a little bit more negative. This is still true. It's probably still positively charged, but we picked up some more negatives because we took them from the neutral object. Now, okay, this one has fewer negative charges than it did before. So now this is not true anymore. Because it lost negatives, it means it has fewer negative charges. Therefore, now it has more positive charges. It is not neutral. We have just made this positively charged. All right, so what are some of the key factors for conduction? One, and the reason why I underline this is contact must be made. All right, so that's one thing. That's why contact, conduction, contact. It's got to make actual physical contact with it. Okay, and then what do we notice? We had a positively charged rod. We made contact with a neutral object, and we ended up with a positive charge. So it produces the same charge. All right, I'm going to want you to know how that happens. It's good to keep these things in mind. All right, if you read a problem that says about describing what is going on in context made, that should immediately tell me, all right, we got to be dealing with conduction. All right, so that helps me to know, oh, if it's positive charge, I'm going to leave that neutral object with a positive charge. So this is true no matter if this is positive or negative, but I'm going to go over what would happen if this is negative. So just, again, a recap. Positive, neutral, it makes contact. The negative charges are attracted to the positive overall charge of the stick, and those electrons move from the neutral into the rod, leaving this with more positive charges than negative and overall positive charge. The electrons are what move. In everything we do, charged by conduction, charged by induction, triboelectricity, charged by friction, all have to do with the negative charge, those electrons moving. So in your explanation, that must be included. It should never, ever, ever say positive charges left this. Not true. Did not happen. All right. So now we're going to deal with this if this was a negatively charged rod. Okay. All right, we're going to have our charges back here again. They will have some positive charges in there, but yeah, more negative charges built up. All right, so this is a negatively charged object because it's got more negatives than positives, right? This is neutral because it's got the same amount. All right, so it's neutral. All right, same scenario, but now we have a negatively charged object. All right, so this comes close again, makes contact. Now, when it's getting closer and going to be making contact, even right before it makes contact, think about that PhET simulation we did with the sweater and the balloon. Right, when you charged that balloon and brought it towards the wall, you saw those electrons begin to move as you brought it closer. Same thing happens when you got a charged object and a neutral object. We got a negatively charged object that's going to come and make contact. It's going to want to actually push these negative charges away from it, right? Because like charges repel. So what that does is it makes this side a little bit more negative, this side a little bit more positive. And now when contact's made, these negative charges are going to they're going to move, okay, through the material from the rod into that neutral object. Now we're going to pick up some more negative charges, and this is not going to be true. Now that's the case, and that is an overall negative charge. Same rules apply. Contact was made, and it produces the same charge. Negatively charged rod, negatively charged neutral object, because electrons left the rod and entered into the neutral object because they were attracted to it, because it pushed all the negatives away to the other side, and now it made this more positive, and those electrons are attracted to opposite charges, and it will flow from the rod into that neutral object. So this is charging by conduction. Okay, keeping track. Conduction, contact must be made. All right, it's going to produce the same charge, and understanding what's going on with the flow of electrons is what you want to be able to explain with charging by conduction. Hopefully this makes a little bit more sense.